So in this section, we're going to discuss the analysis of categorical data. Now, we've looked at t-test, we've looked at ANOVA, we've looked at linear regression. All of those types of tests required numerical data values. So what are we going to do when we want to compare categorical data values? Now, just to remind ourselves of things, what are categorical data? What are numerical data? Imagine I took 40 junior registrars or residents and 40 senior registrars or residents, and I asked them a question and they could rate their opinion on the statement of that question in values of 1 through 5. 1, they don't agree with that statement at all, through 5, they totally agree with that statement. So each of the 40 in each group will answer 1, 2, 3, 4, or 5, each one of them different. I can certainly sum up all of those, divide by how many there are, so I can categorize, or I can at least calculate the mean of each group. I can calculate the variance of each group, and I can compare the means. But that would be actually, I think that would be wrong. Because that would posit the fact that if someone chose a 2 versus someone who chose a 4, that the person who chose 4 was twice as likely or agreed with something twice as much as someone in the second who chose 2. And that's just not proper. There is no set difference between the values 2 to 3 and 3 to 4. When it comes to someone's opinion, you just can't put that exact difference on that. So we're going to make use of something else. Categorical data test. We're going to test by cross-tabulation. So in effect, we're going to create these tables, rows of values and columns of values. Really counts. There are going to be counts, frequency counts in these rows and columns of data. And we'll end up comparing the proportions to each other, the proportions of individuals in each group and their choices in each group. So we're going to talk about the chi-square test for association. And lastly, we'll talk a little bit about Fisher's exact test.